Good morning, welcome back. Hello. So here are the items you'll need for today's lecture. You definitely will need a protractor and compass. We're going to be doing some very simple constructions today. You'll need your scissors and glue, and you've cut out the for-your notes. I've given myself two titles, the large title and the small title today. And then
Drama club members, turn in permission slips for tomorrow's workshop to Miss Olmstead or Mrs. Lee. Thank you. Have a good day.
And then these two pictures, and then these three items. If you didn't save these little titles on it, that's okay. You can write them in. All right, take a moment to update your table of contents. I clearly have some homework to do with my table of contents because none of my page numbers are updated since like forever ago. I'm using the larger of my two titles today in my table of contents. And then we're going to do a quick notebook tour, and all I'm doing is just running my fingers through over the corners. And I'm just trying to see what's coming up. Because oh, you need to get that in soon.
I only have like 2 or 3.
Well, I'll get to it. So I'm just running my fingers over stuff that should be all glued down and putting a little bit more glue just to help it stick a little bit better. And you want to do this every so often in your notebook just to make sure things are sticking properly and you're not going to lose any important bits of information. So here's some of our constructions that we've already done. Our angle relationships. And here was a week before last when the notes were pre-recorded for you. Here's midpoint. Here was distance. And then this is what we did last week where we started our translations. So we had all of our information about how to do translations. We did a translation by construction. We did some examples. We did another translation by construction here at the bottom. And so this needs to be the KWL for Chapter 9, Lesson 2 translation. Which means today's notes are going to start on a brand new page. All right, take a moment to get this next page updated. Yes, ma'am? Do I have a black pen that you can borrow? Yes, I do. Now ask me where it is. There you go. As soon as you ask, I know where it is. Today is the 19th of October. Happy birthday to my husband. Happy birthday to you. Happy birthday to him. He's no longer younger than me. We are now the same age. As always, make sure that you are jotting down the lesson title.
So you're 2 months older than him?
I am 2 months older than he is, yes. So for 2 months, he gets to call me an old woman. Which he does any chance he gets. That's the kind of person he is. All marriage and knowing that one special person for the rest of your life. And don't forget the lesson objectives, our what objective and our how objective. I'm just going to write a brief, shortcut.
Yes, if he calls you old man, you should call him young child.
I do.
Old woman.
I'm like, okay, boy. And he's like, ah. I'm like, well, don't call me a woman. Don't call me old woman.
Wait, so you're born on August the 19th?
August 20th.
Oh.
What?
That's my birthday. It's my birthday. All right.
1972.
Let's kick it off with the important words that you're going to hear used throughout today's lecture. first word is, reminder from last week, what was a transformation?
Where one picture goes to the next.
Where one picture goes to the next, what do we call that?
The change
Transformation.
Yeah, it was a change.
in dilation,
And then we listed a bunch of the transformations we'll be working with.
rotation, reflection, and sign.
Yeah. We'll just shortcut it and we'll go, a transformation is some sort of change.
The change.
It's a change. Today's transformation is a reflection. What is a reflection? Something that reflects.
Wow.
Can we find a way to describe, huh? Yeah, like a mirror. Yeah. How can we describe this without using that word reflect?
A flip.
A flip. That's a really good way to say it. It's a flip. It's a flip. It's not a trap. No, nothing? All right.
The commercial. The social smoking.
And the last word for today is line of reflection.
Ooh, I know that.
What's line of reflection?
Line that reflects.
The
Oh,
x-axis and the y-axis.
The x-axis to the y-axis are examples of what could possibly be lines of reflection. But what is actually the line of
The
reflection?
The
new.
line that
You
you
and I.
reflect
You.
over.
Yeah, the line that you were reflecting across.
That's what I was trying to say.
That is exactly what you were trying to say. I could feel it. Line of reflection is the line across which the reflection occurs. All right, I'm going to go ahead and kick off with the construction examples. And then we'll do the numbers and lead into the numbers for tomorrow. So, our example is a reflection construction. The only technique that you have to remember how to do here is construction of congruent segments. Do you know how to find construction of congruent segments? Bah. Then this is going to be really, really easy. Yeah, right?
The words just slipped from your mouth.
They just, my brain to mouth shut down. All right, so you've got two pictures, and it doesn't matter which one you pick to start with. I'm going to pick the triangle one. And you can put it anywhere you want, but you need to make sure that there is at least enough room for this picture on the other side of the line wherever you glue it. So you can glue it this way because I have plenty of room over here. If you don't like it being upside down and you want to glue it this way, don't glue it here. Because then when you reflect it, you're going to run into your writing. So you have to move it over and glue it here. It doesn't have to be straight up and down. Yes, sir.
Neutral.
It doesn't have to be straight up and down. You can glue it at some sort of angle. You can glue it like this. Okay?
I think we're just gonna copy how you feel.
Whatever you like the best. How do you want me to glue it in?
Upside down.
Upside down?
No.
Like this?
Yes.
No.
Straight up and down?
Straight
This
down,
way?
upside down,
No,
upside
no.
down.
It's easier because you can read the letters before.
You're so good.
How about like this? We can still read the letters just up and down, but we're at some sort of slant.
No, upside down.
Let's do this, and you can do yours upside down.
All right.
All right. I'm gonna glue mine in like this. There we go. Time to bust out protractor and compass.
I'll just copy you.
All right. Taking your pencil.
Taking a pencil.
Your pencil. Now, what we're going to do is The idea behind a reflection is that the distance the object is from the line of reflection has to be the same as its image. Okay? So the distance that this point Z is from this line of reflection K, its image Z prime has to be the same distance. We use perpendicular lines on flat sheets of paper in order to make those distances.
We're still at prime.
Yeah, we're still using the notion of prime. So what I'd like you to do is, you see this little hash mark right here?
Yes.
This little crosshairs? This is in a 90-degree angle with the edge of your protractor. So we're going to set up this line right here on our line of reflection and then slide our protractor until Z is on the edge of it. And then I can just trace the edge of my protractor and I will have a line that is perpendicular to the line of reflection.
What?
Okay?
This is dark. I can't.
So there's our line. Again, I lined up, yeah. I matched up this line here, which is my 90-degree marker, with my line of reflection. I moved my line of reflection, my protractor, until it was, the edge of it was even with Z, one of my points. And then I just traced the edge of the protractor until I ran out of room, because I don't know how long of a line I'm going to need. Repeat this process for every vertex of your
How
figure.
long was?
I don't know until you run out of room, because I don't know how much room you're going to need. So if you're close to the edge of your paper, it's until you run out of paper. If you're up against the edge of your notes, it's until you run into some words.
So is that enough space?
That looks like it's going to be enough space, yeah.
You made 2 lines?
You're going to do it for every vertex.
How do you do it? Oh.
So now you have something that looks like this.
Me.
We all okay with this? Yes? All right. Now, the conversation that I had at the beginning was that the only construction skill you needed to use was congruent segments. So you're going to find the distance between each vertex and the line of reflection, and you're going to make sure that distance is the same on the other side of the line of reflection.
So what are you doing, Miss? Oh.
So I found the distance between Z and line K, and then I marked it off here. If I can get the phones put away, please, so that you can work on the constructions, I'd appreciate it. Thank you. This intersection right here is the point Z prime. Repeat. Repeat for every vertex on your figure.
How do we do X?
Great question. How would I do X? Is there any distance between X and the line of reflection?
Yes.
Oh.
No, it's on the line of reflection, so
Miss, what did you do there?
You never know.
there's no distance here.
What did you do there, Miss?
I found the distance between Z and my line of reflection,
Nice.
and I marked that off on the other side of the line of reflection. Do the same thing to every vertex.
Oh, so you gotta get Z and the X line
Mm.
or the K line.
Yep.
Yeah.
All right, everyone have their points moved?
No.
Go ahead and mark X prime. That's its reflection. It didn't go anywhere, but that's still its reflection. Yeah, X doesn't move. There's no distance. Soon as you have all of your points reflected, trace the, what's it called? Connect them with straight lines. so that you can have those segments.
Oh, what's in the?
And when you're done, your figure should look a little something like this. Almost like a pyramid, right? But remember, these lines are just reference lines. They're not really there. You don't have to erase them. I'm just erasing a little bit so that way they're a little hard to... I'm trying to erase them. Yeah, connect them. There. So they're a little harder to see. If you did the construction properly, the distance between each vertex in your reflection should be exactly the same as the distance between each vertex in your pre-image. The ones that correspond. So take a moment and use your compass just to confirm that each of those sides are congruent to its partner. I did mine okay. Turn it off and put it away. All right. Let's grab the other one and let's do it again. Looks good. All right, let's do this one. Let's do it again.
Is this looking enough space?
Yeah, that looks, you're going to have to find where you're going to have room for it. I think I've got room down here if I trim mine a little bit. So I'm going to trim mine a lot, actually. All right, I trimmed mine a lot.
Inside too?
No, you don't have to do it inside the figure. All right, and I hope I'm not going to run into anything. I'm going to put it right here. That looks like it's going to be okay. It looks like I'm going to have enough room for that other figure right here. And I want you to repeat the process. Do it again. Get your protractor. Set your 90-degree marker on your line of reflection. Line it up very even. And from every vertex, draw yourself a reference line.
Miss, where are we doing it?
Anywhere where you've got room in order to do a reflection of it.
I was just gonna do it back.
Okay, you're going to do it on a new sheet of paper. That's all right. All right, I have all my reference lines.
I have a lot of space.
Good. So you have a lot of freedom. Just make sure that you've got enough room on the other side of reflection for this figure. Do you want to use mine? You're welcome. As soon as you get all your reference lines in, get your compass and start marking off distances. I'm going to recommend that you mark off each point and you label it, bless you,
Thank you.
as you go. A is going to be really hard for me because my compass almost doesn't go down that small. So A is going to be the hardest one for me to reflect.
Ah.
And again, if I did this right, the distances between each of the vertices are going to be congruent between the image and the corresponding sides in the pre-image. Yeah, and really that's the hardest part to these constructions sometimes, is just getting your fingers and hands to do what you want them to do.
Okay, let's try to put this for me. Okay, we're gonna write this down.
Then as soon as you think you've got all the points down, connect the vertices with straight line segments. And then confirm congruence. How close are you? Oh, this one's off, I think. Oh, I measured wrong. Okay. All right, I have one that's off. Take a look. My B prime to C prime is that large. But when I move over to B and C, it's too short.
You almost had this.
I almost had it. So my reflection isn't perfect. That's okay. For your first few bazillion tries, they may not come out perfect. Okay? And allow yourself the, oh man, and you go, well, what did I do weird here?
Almost mine came out perfect.
Awesome. Good for you.
Just like this.
Did you use your compass like this to confirm congruence?
I didn't use that. I didn't use it.
Yeah, this is the way to double check. My A and B came up short as well. See? So my construction isn't perfect. A couple of things that could have gone wrong, and the easiest thing that could have gone wrong would have been right here at your reference line. If you drew your reference line and this 90-degree marker wasn't exactly perfectly 100% straight, your distances are going to be a little off. Okay? So when you're doing these constructions, really try your best to make sure that it is as 90-degree perfect as possible. Okay? And that will make sure those constructions are perfect. I clearly did not. All right, I want to go ahead and end this here today, and we will do this tomorrow when we have some examples with numbers. All right? All right, thank you very much.